Section 10.1.35. A can of soda is labeled as containing 17 fluid ounces. The quality control manager wants to verify that the filling machine is neither overfilling nor underfilling the cans. Complete parts A through D below. So for part A, it says determine the null and the alternative hypothesis that would be used to determine if the filling machine is calibrated correctly. So again, the null hypothesis is capital H with a subscript of 0, and the alternative has a capital H with a subscript of 1. So therefore, there's your null and there's your alternative. Now we have to determine what is the parameter that's being tested. Well, the parameter that's being tested, it says a can of soda is labeled as containing 17 fluid ounces. That means every single can of soda is going to be labeled at 17 fluid ounces. So in this scenario, you're looking at the parameter to be the mean filling of 17 fluid ounces of canned soda. So that means we're using the symbol of mu because remember that represents the population mean. So the null hypothesis always contains the equality, okay? And the alternative has an inequality symbol. So at the beginning of the first sentence, it says a can of soda is labeled as containing 17 ounces. So that means this is going to equal 17 or 17 ounces. Okay, now the alternative hypothesis, okay, it doesn't tell us whether there is a greater than or a less than. So that means that the only other option that we either have a less than, we either have a greater than, or a not equals than in the alternative hypothesis. Since it doesn't contain a less than or greater than in our problem, that means that this is going to be a not equals 17. And so keep in mind that the not equal sign will tell us that it is a two-tailed test. Okay, now let's take a look at part B. It says the quality control manager obtains a sample of 86 cans and measures the contents. The sample evidence leads the manager to reject the null hypothesis. We want to write a conclusion for this hypothesis test. Okay, now, when the null hypothesis is rejected, then we would say that the alternative hypothesis is supported, meaning that the population mean does not equal 17. So we would say that this means that there is sufficient evidence to conclude that the machine is out of control. Okay, let's take a look at part C. It says, now suppose in fact the machine is not out of calibration. Has a type 1 or type 2 error been made? Okay, well let's go over type 1 and type 2 errors. A type 1 error is committed when the null hypothesis is rejected, when in fact it is true. A type 2 error is committed when the null hypothesis is not rejected, when in fact the alternative hypothesis is true. Now, type 1 error has been made since the sample evidence led the quality control manager to reject the null hypothesis when the null hypothesis is true. Okay, now let's look at part D. Part D states that management has informed the quality control department that it does not want to shut down the filling machine unless the evidence is overwhelmingly that the machine is out of calibration. What level of significance would you recommend the quality control manager to use and then explain? Well, the level of significance alpha is the probability of making a type 1 error. Increasing the level of significance makes it more likely to reject the null hypothesis. The level of significance should be 0.01 because this makes the probability of type 1 error small.